Okay, in this video I'm gonna do an example of finding a particular solution for a differential equation, and basically what that means is just finding the value of c at the end, the constant, arbitrary constant. So we've got our initial condition here, which is y of 1 equals to 2, and basically what that means is just when x equals to 1, y equals to 2. And we're going to plug in these values later after we do the integral, solve the differential equation. So let's see what we've got here. So we've got y plus 2 over x squared minus x plus 2 times y dx equals x over y. So let me just zoom in a little bit in here. Yep. So what I'm going to basically do is just cross multiply here. So let's just consider this as a multiplication here. It's going to be dy times that. So what I'm going to do is just cross multiply here, right? So it ends up with y times y plus 2 dy equals to x times the denominator 2 dx. Oops, sorry. So what I'm going to do next is just distribute the y inside the bracket. The same thing for x as well. So if we distribute that, sorry, it's going to be y squared plus 2y dy, right? Same thing for here, x times inside the bracket, x to the power 3 minus x squared plus 2x all times dx. So that's much easier. Now we can just integrate both sides, right? So if we took the integration of both sides, let me just zoom out now. So in that case, we're going to be left out y squared, the integration of that is y3 over 3 plus, well, it's going to be y squared, right? The two would cancel each other out with the power, and then that would equal to x to the power 4 over 4 minus x to the power 3 over 3, and then plus x, that's a plus by the way, not an x to the power 2 x squared, and then plus c. What I'm going to do here, I'm not going to do anything, I just do it straight away. So I'm just going to substitute the values of x's and y's with what we got here, the initial condition, to find what c, right? So I'm going to substitute all the x's with 1, and substitute all the y's with 2. So let me just do that on the new page. So let's substitute all the values of x's and y's to the original formula. So so the initial conditions are y equals to 2 when x is equal to 1. So I'm going to substitute all the y's with 2. So that would be 2 to the power 3 over 3 plus 2 to the power 2 equals to 1 to the power 4 is just, I'm going to substitute all the x's with 1, because anything to the power 1 to any power is just 1. So, and then plus 1, and then plus c. Now we just simplify it by making c the subject, and we're gonna get c. So here it's gonna be 2 to the power 3 is just 8 over 3 plus 4, and then now I'm just gonna pull that on the other side by the opposite sign, just to make c the subject, right? So this would become minus 4th, and then that would be positive 3rd, and that would be minus 1, and that would equal to c. And if you do that by the calculator, you get that c equals, if you just do that by the calculator, we get c equals to 23 over 4. So that's the solution. That's C, 23 over 4. But to write it to write in a neat way, what we can do is just we rewrite this down, yeah. But instead of C, we just put 23 over 4, just to make it in a proper form. But it's up to you. As long as you've got C, that's, I don't know why I'm saying T, because I need tea actually. I'm thirsty. So we're going to substitute C with 23 over 4, and rewrite this whole thing, but with a substitution with the C value, and that's your solution.